So we stopped at here with the IK pose. Let's continue. Right. Now let's implement right hand IK pose stuff. But do that, what we can do is I'll get this IK pose cache, and there is a specific node called two bone IK. Let's use this thing. Right. And here as the IK bone, I'm going to manipulate at first the hand R, and for the effector we can make it as bone space manipulation, and the effector target should be IK hand R, and the effector location we can use this effector location hand R. Effector location hand R. Yeah. And for the joint target, so this is the effector, and for the joint target again we can use the bone space, which is upper arm R, right? Because if you look at our skeleton hierarchy, the upper arm L is there, upper arm R is there, right? So we can use this as a joint target location. And as the joint target location, we can use this one, joint target location hand R. Joint target location hand R, right? So what we'll simply does, we have initialized the hand IK right hand stuff at here, so it will apply this offset to our upper arm R bone, right? So here you can see I'm adding sort of offset for the y-axis. So at here, this hand R at the joint target location upper arm R, it will add that manipulation, right? So here you can see, like, in that way we can configure the offset at our data table level, and they will be automatically applied at our blend space level, right? So nothing is hard coded. Okay, and then we need to resolve this alpha as well, right? So alpha, we can keep it as 1, but actually we can keep increase this alpha when we are rendering the frame, right? So let's see how we can do those stuff. So if I go to my blueprint thread safe functions, I have a set of functions defined here. Yeah. So I'll create another function called update skeletal control data, right? And this should also take data time as the input. So I'll add an input field called data time, which is float, and this should be thread safe. And I'll add it to the very first function before calling the update location data. Because I think this is sort of important, because it is sort of manipulate the skeletal controls. So let's do those stuff at the first. Right, and I'll go to the implementation of the function, and there let's float interp our hand ik, right? So float interp to hand ik. And let's promote this to variable and call it as hand ik, or let's say hand r ik alpha, right? And we have to float interp this one to here as the current, and as the target will be depend on whether we have enabled or disabled the hand ik. So since this one is for hand rik, I'll get this disable hand rik and select it accordingly. So if this one is disabled, then it should be 0, otherwise it should be 1, right? No, it should be the other way around, right? If I disable, it should be 0. If I enable, it should be 1, right? As the delta time, we can use the delta time, and in time speed I will simply hardcode it as 4, 5, right? Okay, and then you can clamp it, because the IKs always vary from 0 to 1. So let's clamp the float from 0 to 1 and plug it to here, right? And additionally, we can further control left hand and right hand specifically by using curves, like we did at here. So let's give that capability to here as well, right? So later on, actually, we can use those curves if required to disable the hand ik explicitly, right? Okay, so in order to do that, let's get the curve value. So we have this disable hand ik curve here. So I'll use disable hand rik as the curve value and promote it to a variable called curve disable hand rik. Move it to here. And then then what we can do then, yeah, we can actually add another layer of curve, because since we have the disable hand ik, we can check whether the returning value from this curve is greater than some value. So I'll add some smaller value like 0.001, and based on that we can make a selection. So if this one is true, we can reduce some value from here. So if this one is true, then we can directly remove the entire alpha. So I'll add 1. Otherwise, we can reduce it based on the curve value provided here, right? And then we can plug it to here, and at the end it will be clamped, right? So hope you get what I'm saying. Basically, like if we explicitly disable the hand ik by using this curve, we don't need to even consider the value provided at here, because the entire hand ik has been disabled. Therefore, we can simply use 1 and reduce it from here. So the return value will be either 0 or 0 or closer to 0, and it will be clamped to a 0 and 1 and add it to the hand R IK. Right? But if we haven't used this curve, then it will use this curve, which means the curve values provided by this curve will be used to adjust its IK values, right? And then until it will be clamped and add it to hand R IK. Right. So then this is for hand R IK, so I'll plug it to here. And similar setup we can do for left hand as well. Therefore first I will add a sequence and let's comment this thing and I'll call it as and RIK alpha calculation. Right. And I'll copy the entire set, paste it here, plug this one. This should be hand LIK calculations. So instead of hand disable hand R, I will use disable hand LIK, and instead of hand RIK alpha, let's promote it to another variable called hand LIK alpha, and plug it to here. And here let's use hand LIK alpha as the current value. Delta time we can keep as it is, interrupt speed also fine. And here I'll duplicate this one and rename it to hand LIK, and the value also should be renamed as disable hand LIK. And instead of this disable hand RIK, let's use that curve which is disable hand LIK. Okay. And then this one is fine because this is a global disable of hand, so it's fine. And clamping and hand L alpha. Okay. Right. So that's how we calculate the alpha for each frame for a smooth transition of the IK placements, right? So I just calculated both hand RIK alpha and RL alpha at here. So later on we can simply reuse those stuff at our emulator. Right. Then let's go back to our full body skeletal controls. And here as the alpha, I'm using a float value, and the float value should be hand no, it should be, yeah, hand RIK alpha because I'm manipulating the hand R, right? Then we can use this IK pose and blend it with each other. So let's use this IK pose and let's get this joint target bond hand R and blend it based on those hand IK bond types. So select this blend pose E hand IK bond type because that's the enumeration that we have been created, and there we have to get the upper arm and lower arm. Let's compile. Right. And let's right click on this and let's add a pin. So first let's add upper arm and then let's add lower arm. And for the default pose I can use this IK pose, and for the upper arm I can use this one as well, right? And what can be used for the lower arm? Right. So for now I will use the exact same for the lower arm as well, but I think we can't add multiple pins. You see, it only works for one path. Then let's simply duplicate this thing and paste it over here, and I'll use that path like this, but it's the exact same thing. Okay, and this is basically the right hand IK. So I'll save this for a cache pose called hand R IK pose. Okay, and then we can do somewhat similar thing for left arm as well, but first I'll make some space and copy the things and paste it to here. And here, instead of using IK pose, let's use hand R IK pose, and here also it should be the hand R IK pose, and the default one should be the hand R IK pose. And for this one, the bone should be hand L instead of hand R, and the effect bone space also should be IK hand L. The effector location should be effector location hand L, and the joint target should be I think we can keep it as upper arm, but it should be the upper arm L, and this should be joint target location hand L. And I'll copy it to here and replace it like this. Okay, and the blend pose would be fine. And the return pose should be saved to cache pose, and I'll call it as hand L IK pose. Right. So this one is for hand L IK. And then finally I will use that hand IK hand L IK pose as the output pose. So I have this output pose. Let's plug it to here. Okay. So I'll comment this stuff just for the reference. So these are like initializations, and this is and lik blend, and this one is and rik blend, and this one is the output pose, right? Okay, and I think all good. So let's play test. Right, so let's equip this rifle and see whether it's been applied properly. No, still when we are moving, and IK is not applied. I think I know the reason, because in our data table for rifle, yeah, the both hand, left hand and RIK has been disabled by default, right? Because for the optimizations, and I think we have to enable the left IK for that, right? Because you can see the left hand is the one which doesn't have the proper hand IK, right? The right arm is having the IK because it is being held in the rifle properly, but left arm we should add that joint target location offset, right? So if I select the rifle, and for jog movement group at the config, let's enable this left hand IK, and let's play test it again. Okay, I think sort of offset is there. No. Okay. Say -100. -500. No, it seems IP doesn't been applied for the left hand. Yeah. Right. I think I found the issue. So the issue is actually I forgot to switch this alpha value at our full body skeletal controls enable layer, right? So here you can see for hand L, actually this one is hand R, right? So I'll rename the command called hand R. So for hand R blend, I've been used this hand RIK alpha in both places, and here this should be hand L. So this hand L manipulation, I forgot to actually switch this one to hand LIK alpha, right? So let's change it to hand LIK alpha, and at here as well. and L like alpha. Right. Now let's compile and save and play test it again. Okay. Seems there is sort of improvement. Instead of using the lower arm, let's manipulate upper arm. Right. So for now, let's disable this hand IK for a while. And yeah, now let's play a test. Okay, so now we don't have a hand IK. But let's go to a mannequin and select this rifle socket, right? So in this rifle socket, I see some relative offsets that has been added for location and rotation. So let's get rid of those stuff first. So 0, 0, 0, this one 0, 0, and let's add a minus 90. Right, so I just reset the location and rotation and maybe the scale as well, one by one. Right, and then now let's play. Okay, the gun is other way around. Okay, instead of adding these two hand R, let's add these two weapon R, because it is a virtual bone. This is a bone actually at here. Okay, so let's add that to here, weapon R, and let's play it again. Right, now the weapon is pretty much accurate, see. Okay, and let's apply the hand IK for left arm when the rifle is in the jog movement mode. Okay, now it seems almost good. I can see some IK is being applied and the hand is on the weapon. Left hand is on the weapon. Okay. Maybe let's move it to the lower arm and see how it works. I can see some sort of a snap happen for the weapon equip at the hand IK. So for now I'll just disable it, and maybe we have to improve our equip method further. But yeah, anyway, now the IK is working and the hand placement is resolved now. Right, and then let's fix the pistol as well. So for the pistol, I'll move it to the weapon R and I'll reset these relative locations for the default ones, minus 90, and let's play a test for the pistol and see whether it's working properly or not. Okay, now for pistol also it works. So pistol, let's try, and okay, pistol be upper arm. Here, so for pistol actually it works properly, like no swapping when we enable the hand eye key. See, the bone properly manipulated at the joint target location. Maybe we can add -100. Yeah, -100 seems good for me. Okay. So it's for the pistol and rifle. You don't need to actually add any hand eye key for unarmed or sword, because at the unarmed actually we are not carrying any sort of a weapon, and at the sword actually we are carrying a weapon at only one arm, right? So we don't need to actually consider about the hand eye key of the other arm. But considering the pistol and rifle, actually the weapon is equipped by both hands, so we have to carefully manipulate the eye keys. But yeah, now I think everything works properly. So pistol, we have it, and I think we have to do it for both walk and crouch states as well. Let me see. Yeah, for pistol, at the walk we have to add left hand eye key for the upper arm, and for jog we have been added eye key for upper arm, and similarly for crouch as well. So let me quickly see. Yeah, for crouch also let's enable hand eye key for the left arm upper. Right, now let's play test. Okay, so walk, it works properly. With jog it works properly, and for crouch it works properly. Hand eye key is there. Right, and let's test for rifle as well. Okay, for jog it's there, and for walk also it's there, and for crouch, yes, the left hand eye key is there. Awesome. Right, so bit of a complex procedure that we have to follow, but yeah, that's how we can implement the hand eye key. So if I quickly recap what we have been done, yeah, I'll organize this function properly as well. So this is the function that we had for skeletal controls data. So I'll add it to blueprint thread save functions, and the curves are there. And this hand arc alpha and R and L like alpha, I'll move it to skeletal controls hand eye category. Right. So if I quickly recap what we have been done, first we have created a data structure called hand eye and added it to its anim set, movement groups, anim configs, so that all those configurations are available at our data table. So we can independently manipulate either left hand eye alpha or left hand eye or right hand eye with these weighted parameters for these effective locations. And at the animation blueprint instance level, first we extracted data at set animation data configs. So here I have been extracted both IK related hand IK related configs for left hand and right hand, and initialize their respective variables. Yeah, I think I have missed this one and I gave it. That's good to find, right? Okay. That's a one benefit of having a recap, right? So we can instigate like these sort of mistakes, right? So this is a very important part, right? So make sure to plug that thing. Even I just forgot to add those to here, right? So all the respective variables are initialized here, and then I have created the animation layer called full body skeletal controls, and inside these skeletal controls there are some initializations happen, and there are two types of blendings for both hand R blend and hand L blend, and finally the outpost will be returned. And then we can maybe do a final testing. We can see hand R and handle like has been applied for both rifle and pistol. Each and every individual states it works. So jog also work, walk also work, and crouch also work, right? So that's how we add hand IK, and I think we are almost done. But later on, actually, if we face some issues related to hand IK, we can quickly resolve those stuff at here at our data table. And yeah, so that's it. I'll see you there. Thank you.